In this video, we will be looking at proof by mathematical induction. So we want to prove that 3 plus 6 plus 9 plus plus 12 plus 15, going on in that fashion, plus 3n is equal to 3n n plus 1 all over 2. We want to prove this by mathematical induction. In the proof for mathematical induction, there are three phases. One, there is a basis that we test for the truth. Alright? So a basis that we test for the truth. So these are n's. Alright, nth term. So this would have been, this is a series because we're adding. So it's summing up each time. So what we're saying, when n is equal to 1, the sum is going to be 3. We're also saying when n is equal to 2, meaning the sum of these two, we should get 9. And when n is equal to 3, meaning the sum of these 3, we should get 9 and 9, 18. So when we say test for truth, we want to test for truth where n is equal to 1. So we want to test this by plugging in 1 where n is and see if it's going to work out to give us 3. So that would have been some basis that there is some truth to what we're doing. So what I'm going to do now is to do the test. I'm going to do the test. So 3 should be equal to, so this is I'm testing where n is 1. 3 is equal to 3 times 1, open bracket, 1 plus 1 all over 2. So if we finalize this, 3 times 1 is 3 outside, times 1 plus that is 2 all over 2. So we see the canceling there. 2 cancel 2. So we're seeing for real that when n is 1, then the term, the first term, would be 3. So that's the first step. We test for truth. In the second step, what we're going to do now is just going to assume that n is equal to k. So we're going to try something else other than n to see if this holds, right? So let's assume, all right, we want to assume that n is equal to k. So this means we're going to rewrite this. So now we're going to assume that n is equal to k. We are going to rewrite everything and substitute k for n in this original form. Alright, because I have space issues, I will, rub out each time to get what I want. So now we have the test for truth. So it's going to test that 3 plus 6 plus 9 plus in that fashion, plus 3k is equal to 3 times k plus 1 all over 2. So now we want to assume that this is true because we just proved that n is equal to 1. So now we're substituting k for n, and we are assuming that this is true for k. The final step is the fact that we now need to take it one step further. We need to prove this true for k is equal to 1. So in this case, we're going to let n is equal to k plus 1. So we're going to prove this true for k plus 1. Alright? So what we're going to do now is to rewrite this, substituting k plus 1 wherever we have k, and then we're going to see what happens. So we're rewriting this now for k plus 1, right? Alright, so in this case we're looking at 3 plus 6 plus 9 plus dot. Alright? And then you would have a 3k plus 3k plus 1. That will be the final. So this is just one more 3. So, alright. Let me write this better. 3 times k plus 1. All right? So we want to see that true for that. But what we will have on this side is going to be 3 times k plus 1. And then beside this, we'll actually have k plus 1 for this k, but there is always a plus 1 also out there. All right? And all of this must be over 2. So if we simplify this part, we actually have 3 k plus 1 k plus 2 all over 2. We simplify this, get that. So what we're saying now, we want to prove all of this for k plus 1. All right, so that means I'm supposed to get this, like 3 plus 6 plus 9 plus 3 plus k plus 3k plus 1, all of that must equal to this. Now, I'm supposed to prove that this left side is equal to that. But what we do notice is that on the left side here, all of this, from the 3 adding up to the 3 plus k, we had that already. All of this up to 3 plus k, this is equal to 3k times k plus 1 over 2. We already know this. All right, up to this part. Therefore, if we add this to it, I think I wrote that bad. All right, 3k plus 1. All right, people, I made an error there, so that's it. Sorry. So 3k plus 1 over 1. We are supposed to use this, and it should equal to that. So let us see quickly if we could multiply this out. In our multiplication, basically what we're going to do is just to do some regular fractions. So it's going to be this time this time this, all over that. So hopefully you would have some algebra skills up your sleeve. So we're looking at 1 times this. So it's going to be 3 k plus 1, because 1 time anything is itself. 2 times that. So it's going to be 2 times 3. I'm going to put 6. All right, and then I'm going to put k plus 1 there, all over 2 times 1, this is 2. So if I take this further and I do cancel, all right, let me see if I could go a little bit further. Yeah, I could go a little bit further down. So let's simplify this quickly. So what I'm looking at now is 3k squared plus 3k, so that's 3k squared plus 3k plus 6k plus 6. All of this is over 2. And it should equal to 3 times k plus 1, k plus 2, all over 2. This should be that when I'm finished. Okay, as I said, I have some space problems, so I'm going to bring what I have down here all the way up at the top, okay? Alright, so I'm bringing this all the way up to the top. Alright, all the way up to the top. Okay, all the way up to the top. Need some space to work. Alright, so here it is. Let me bring this up. So I'm looking at the top, I have 3k squared plus 3k plus 6k plus 6 all over 2, and it should equal to 3 k plus 1 k plus 2 all over 2. Alright, so my next step is to simplify this. So I'm looking at 3k squared plus 9k plus 6 over 2. And then you can see if I do take this, so I'm going to just work this on this side, because I'm still aiming at that. So if I do take this, I realize now that, hey, I have a common factor here of 3. I could factorize out the 3. So if I factor out the 3, I'm having k squared plus 3k plus 2 all over 2. This is me factorizing that. I need a little space to go further. I hope this is not affecting what you're doing. Alright, so, alright, remember I'm still trying to get my that. But if I do factorize this, alright, so here it is, but if I factorize this, what I'll do get at the top is a K, alright, I'll get a K, I'll get a +1 and a +2, alright, if I factorize out this, alright, and it is all over 2. So now you could see that I took the left side and I actually work it to get back the original thing. So there it is. There is the proof by mathematical induction, all right, that 3 plus 6 plus 9 plus 12 plus 15, and so on, plus 3n is equal to 3 over n, is equal to 3n into n plus 1 all over 2. Alright, so basically, thank you for watching, and I hope you'll subscribe and like this video. Thank you.